Braylon.
I'm Andrew. This is our Math 217 project, and today we're going over square root functions. So, to start off, basically the parent function is y equals the square root of x, and for this basic function you have the domain being 0 to infinity, and the range also being 0 to infinity, and it can also be written as f of x equals x to 1/2 power, so don't be confused by that. And also, something I forgot to put down was this is kind of what the graph would look like. Not exactly like that, but that's roughly what it would look like. So, okay, so we're going to have our first addition to our parent function, and that is we're going to be putting a number in front of our parent function, and that's going to be represented by a. So we notice that graph stretches or shrinks when we vary a. So when the absolute value of a is greater than 1, then it's a vertical stretch. And when it's between 0 and 1, this would be an irrational number, then it's a vertical shrink. So you can see this by the graph that I just made. Y equals 2 times the square root of x, and y equals square root of x. Y equals 0.2 times square root of x. I just started.
So another example we have here is if a is less than 0, then the graph y equals a of the square root of x. Then there is a reflection in the x-axis of the graph. So for an example, if you have y equals a positive a to the square root of x, this is where it would be. But if you had the same a but it was negative, then it reflects from the previous positive over to the negative side of the x.
So one good thing to note is that the reason the graph looks like this, the reason it starts at 0 and goes up, is because the x under the radical sign cannot be anything less than 0, or else it's undefined. So that is the reason this graph looks like this. Alright, so for this part, we're just going to be focusing on the c of our square root function. And for this part, you're going to be taking note if it's positive or negative. If it's positive, then it'll be moving up this way, positively, obviously. And if it's negative, then it's going to be moving down here. So, so you can see in this equation, it's plus 1, so we're shifting our graph up 1. It's still the same graph as this one, but it's just shifted up 1 more. And so you can note that the range is now everything greater or equal to 1. And here, the range is now greater than or equal to -3. But it's still the same graph with the same slope.
Okay. Now we'll be talking about translations in square root functions. So as you can see, we have y equals the square root of x plus c. So first we see that c is greater than 0. And it will shift up whatever c units is. It could be 5, 1, or whatever it is. Whatever c is, and it shifts up that many units. If c is less than 0, then it shifts down how many units whatever c is. And for a vertical stretch and compression, for y equals a of x, if a is greater than 0, then there's a vertical stretch. If a is greater than 1, there's a vertical stretch. If a is less than 1, there's a vertical compression. And if a is less than 0, there's a reflection in the x-axis.
And then for horizontal translations, this would be y equals square root of x minus c. If c is greater than 0, then it shifts to the right c units. And the opposite of that, if c is less than 0, it shifts to the left c units. And then horizontal stretch and compression, this would be y equals b square root of b times x. So for horizontal compression, the absolute value of b, if it's greater than 1, then that's horizontal compression. And if b is less than 1, then it's horizontal stretch. And if b is less than 0, then there's a reflection over the y-axis. Alright, so for our application of business portion, we're going to be using this graph, and this is more of an economics kind of application. So not exactly business, but they're one and the same. For this, we're measuring the value of slices of pizza and relating that to the cost. So we're kind of using y equals square root of x for this, because for each unit of pizza, it becomes less valuable to us. So the first one is very valuable to us because we're really hungry. And then the second one is a little less valuable. You can see that by the slope becoming less and becoming flatter. And then as you go higher and higher, it becomes less valuable until you get to the point where your value and your cost cross right there. So there you go.